So I'm now going to introduce you to Phoebe and her second participant, national finalist, competitor, whichever word you'd like to use, Duncan. Now, Duncan is currently at home as he's poorly, but he's been very resilient and he has recorded his clip when he was a little bit more well so that we can play it to you all. He's put a lot of effort into this clip and he's really disappointed not to be here, understandably. But I think it's really important that we celebrate him just the same. So I'm going to hand you over to Phoebe and she's going to talk a little bit about Duncan's topic because I know it's much too technical for me.
Amazing, thank you. Yeah, I know Duncan's really gutted not to be here, but I think he'll still get his incredible message across. I've learnt from everyone, but I learnt a lot more science than I've ever learnt at school, and the future of antibiotic resistance from Duncan, and the way he puts it across. I was never, top of the class at science, but I got it the minute he put it across in the way he's going to put it across to you, and it really excites me, and I hope it excites you just as much.
It's December 2019. The world is heading unknowingly into one of the worst pandemics that we have ever seen. Yet a silent killer already has begun its killing spree on our globe. 1.2 million people dead. By 2050, this could kill more than cancer. How, you might ask? A rise in the use of antibiotics has caused an increased resistance to them. Once treatable bacteria, now incurable. Unless we act now, we could face another pandemic, as minor bacterial infections become untreatable. I'm sure that many of you know what antibiotics are, and many of you have taken them at some point in your lives. But what do they really do? Antibiotics are a form of drug that affect the cell processes of a bacterial cell. For example, some prevent the reproduction of the cells, some prevent the production of proteins in the cells, and some break down the cell walls. So how can the drugs be reducing in efficiency then, if antibiotics have been functioning for so long? The answer, worryingly easily. The overprescription of the drugs means that more drugs are given to minor infections and to patients where the drugs simply aren't necessary. Upon introducing the antibiotics into population, there is a fight for survival of the pathogens, meaning that only those with the highest resistance can survive. Lots of patients then feel better, finish the course early, and leave the drugs in a drawer somewhere. Forgotten. The few bacteria that are left then reproduce, passing on their resistant genes to the next population. In a very short period of time, this process can repeat until all the bacteria in the resultant population are resistant. While this may seem like new information to you, we've known about antibiotic resistance since the 1950s. Only now are we realising the damaging prospects of this all too real danger. Now that we've established the cause of our public health powder keg, the study of MRSA, a so-called superbug, can provide some stark statistics that are vital in our fight to the next global threat. An average of 800 cases of MRSA each year have been recorded in Britain. Thankfully, case rates have stabilised due to increased hygiene in hospitals, meaning it is less likely to be transmitted within treatment areas. Furthermore, this bacterium is treatable by vancomycin, a drug that inhibits the production of bacterial cell walls. However, a new variant of MRSA, known as VRSA, has been discovered. Being resistant to vancomycin, could it foreshadow what is to come in an era of antibiotic-resistant bacteria? Thankfully, our future is not set in stone. There is a way for us to free ourselves from this disease-ridden dystopia. There is a major effort to redevelop an old treatment to this new type of bacteria. Bacteriophages. These are a type of virus that can insert DNA into a specific bacteria. After inserting their DNA, the bacterial cell starts to produce more phages, until the cell bursts open, killing it in a process known as lysis. Although it may seem somewhat counterintuitive to use viruses to treat bacteria, pitting two major pathogens against each other, bacteriophages cannot harm human cells, so are perfect for use in the body. What's more, even in the worrying scenario that a bacterium were to develop resistance to the phage, it loses its resistance to antibiotics. With the inevitable decline in the use of antibiotics, we have no choice but to study these marvellous assassins more carefully. Another unsung hero in the fight against antibiotic-resistant bacteria is the media, which has played a large part in increasing public awareness of the issue. I'd like to ask, how many of you have seen the NHS's advert about antibiotics and antibiotic-resistant bacteria? The use of the medium of song has ingrained the message of not asking for antibiotics for minor illnesses into our minds. Due to increased awareness in the healthcare industry, antibiotics are now no longer issued for chest infections or child ear infections or sore throats. Despite these changes being small, they are our first steps to decreasing our dependence on antibiotics. Now, on sitting down earlier, some of you had red pieces of paper on your chairs. Could you stand up, please? This is roughly 40% of this room. You represent the 40% of people who will die prematurely as a result of the antibiotics stopping working. It seems that bacteriophages and the media may be our only hopes of salvation, lest we are condemned to a world where bacterial infections plague our lives. Although, if we act together now, if we only use antibiotics when absolutely necessary, if we administer them properly, then we can reduce the pernicious effects of this silent killer.
Because I know Duncan is joining us from home, I would just like to say a big thank you to Duncan for his interaction and for working really hard to make sure that he could participate virtually. I know it must be really difficult. For those who know me, I cannot work my iPhone, nor do I know how to turn on my laptop. So that must have been really challenging because I don't really think I know where even the cable for the mouse goes. I do just leave it plugged in.